You see, it's like this. There is a there is a car. There is a car, and if the car is moving, if the car is moving in a horizontal this thing, then it applying a force, engine force, and that into velocity is the power of the engine. So now when the speed is moving at constant speed, that means this there's zero acceleration. Acceleration is zero. If acceleration is zero, resultant force, resultant force is zero. Resultant force on car is zero. If resultant force on car is zero, means that F engine is being equal to the resistance. That means agar this is there's a resistance behind and they are equal. That is why this F resultant is nothing but F engine minus R. So if this is zero, so naturally this will become equal to this. And in this question, I I can write power is equal to F engine into V, and power is 16,000 watt. F engine you can get, velocity is given, and that will be give me the resistance. So this part is then. Then what happens is he says now the power is increased. The power is increased. Find the acceleration if it is traveling at now. If when F engine is equal to resistance, acceleration is zero, speed is constant. But now there is an acceleration. So acceleration is something. That means F engine must not be equal to zero. That means F engine minus R must be equal to MA. So the if the again the power is again given by power is given by F engine into velocity. Now this is the power at uh, 22.5 and he's traveling at this. So at this moment, what is F engine? So F engine is equal to 22500 divided by 45. Now this the resistance will come from here because that must be fixed. So now we have got a resultant force F engine minus R. So whatever you get the value here, you put it here, this you get from here, and that is equal to MA. And mass, do you know the mass? Yes, you know the mass, and then you get the acceleration. So in this case, so there will be two cases. One when acceleration is zero, constant velocity. In that case, F engine and R is equal. Sometimes the F engine will be greater than R. In that case, you will have acceleration. But power can give you both F engine at that velocity and that velocity. In the third part, in the third part, again the same thing works. Is constant speed. So once he says constant speed, we know F engine is equal to resistance because there's the resultant is zero. So resultant is zero. F engine is equal to R. Now he's again giving you 16. This time he's given you power. So power by V, but we don't know V. He says find this V. So we can just write 16,000 by V. Resistance again he's saying is dependent on the velocity. So this in this part of the question the R is changes according to velocity. But whatever maybe R, it is at constant speed. F engine is equal to this. So this is the relationship and you will have to solve for this. So in each part, see the first part, constant speed, F engine is equal to R. See the second part, F engine is there is acceleration. When he talks of acceleration, F engine has to be greater than R. R will come from the previous part, and you will get F engine. You know F engine by power and acceleration. And the third part, again constant speed, acceleration zero. Again F engine is equal to R, but this time F engine comes from power, but the speed is not given. So we write V, and the resistance is also dependent on V. Sometimes it is fixed, sometimes they give it in V. So three parts, you should know what is happening in each part. I'll show you the answer. The first part, he found F engine by using 1600 by 40, and that made it equal to R. So he is made it equal to R. Next part, he's showing you that F engine is greater than 400. The resistance is taken from the previous part, and he's getting MA. In the third part, he's saying that uh, this is uh, this is the resistance, and F engine and resistance are equal. So resistance F engine into V is 1600. So each part you should understand what's happening.